Okay, so this is our last video for the carbohydrates chapter, and I just wanted to wrap it up with some chemical properties of carbohydrates and chemical reactions. So we've already mentioned this, but digestion of carbohydrates is all about hydrolysis reaction. And carbohydrate digestion begins right in the mouth, where you have the amylase enzyme will begin to catalyze the hydrolysis of the starches, the amylose and the amylopectin. And what will happen is the starch, both amylose and amylopectin, will eventually get turned into maltose, which will eventually get turned into glucose. So all the starch you're consuming will eventually just become glucose. Why? Because you've got the amylase enzyme in your mouth and in your small intestine, pancreatic amylase and salivary amylase, chopping all those glycosidic bonds, the alpha-1,4s, the alpha-1,6s, until eventually in the small intestine you have thousands and thousands and thousands of just pure glucose. All right. All your disaccharides, they're all going to be hydrolyzed in the small intestine. All right. It's only the starch that begins hydrolysis in the mouth with salivary amylase. So the enzymes we're looking at are amylase, and then we also have maltase, and we have lactase, and we have sucrase. Amylase will work on starch. What will it eventually turn starch into? Just pure glucose. Maltase works on maltose. That's in the small intestine. What will it turn maltose into? If you break the glycosidic bond of maltose, remember, maltose is just made up of two glucoses. So you break that glycosidic bond, you end up with glucose. Lactase works on lactose. What is lactose made up of? Galactose and glucose. So if you have the lactase enzyme, it breaks the glycosidic bond, and what do you end up with? Galactose and glucose. Okay? And then finally, sucrase, like these three, maltase, lactase, and sucrase, they're all in the small intestine. Sucrase works on sucrose. What is sucrose made up of? Glucose and fructose. It breaks that 1,2 glycosidic bond, and now you have glucose and fructose. So at the end of carbohydrate digestion, you just have a pool of monosaccharides. What are those monosaccharides? Glucose, galactose, and fructose. And then they all go through the villi into the bloodstream. Okay? So that's digestion. You should know the names of the enzymes. You should know the end products of digestion. You should know that the only thing that begins digestion in carbohydrate digestion in the mouth is the amylase for starch, but all the disaccharides are down in the small intestine. Okay? Now, the other thing that I want you to know is the difference between a reducing sugar and a non-reducing sugar. So all the monosaccharides are considered reducing sugars. What does that mean? It means they can get oxidized. Remember how we said that you can't have oxidation without reduction? So what they will do is they'll get oxidized and they will reduce some chemical, all right? And we use that phenomenon to test. You know how they test for diabetes? Well, in the olden days, they used to use a test called Benedict's reagent. And Benedict's reagent was made out of this copper compound. And let me write this down for you guys so that I'm going to get rid of the digestion and talk now about reducing sugars. What is a reducing sugar? Reducing sugar are all the monosaccharides. So basically, glucose is a reducing sugar. Fructose is a reducing sugar. Galactose is a reducing sugar. And then all the disaccharides that are alpha or beta 1,4. Okay? Not the 1,2. 1,2 sucrose is not a reducing sugar. So we'll write down lactose, and maltose. So all these are called reducing sugars. What's so special about them? They can get oxidized. They can get oxidized. And they will reduce an oxidizing agent. Sorry, it's probably very messy handwriting, but you get the idea. So what's the big deal? Well, before they did the dipstick technique where they have, now it's like a glucose oxidase test, they used to use Benedict's reagent. Benedict's reagent is a copper +2. It's blue in color, okay? When glucose, like they'll take a sample of the urine, and if there's glucose in the urine, it will reduce this copper +2 and turn it into copper +1. Okay, so this is a reduction of the oxidation number. Don't worry about those details. But the copper +1 changes color. It's a red color. So this is the what they used to do as a test for diabetes, the urine test for diabetes. They would put Benedict's reagent, which has this copper, and a sample of urine. Now, if the urine's not supposed to contain glucose, but if it contains glucose and enough of it can turn this Benedict's into a red color, that means the glucose got oxidized and the Benedict's got reduced. And because the Benedict's got reduced, it changed color, and then they know, oh, this person's got glucose in their urine. They stopped using it because Benedict's will also test for these guys, not just glucose. So now they do use a specific glucose oxidase test, which is that dipstick, okay? Which ones are considered non-reducing sugars that will not change the color of Benedict's? Everything else. So glucose, fructose, galactose, lactose, and maltose are reducing. I'm going to erase this, guys, and I'm going to write down which ones are the non-reducing. Non-reducing are sucrose, and then all the polysaccharides. So we're talking amylose, amylopectin, glycogen, cellulose. None of those can reduce that copper +2 and turn it into copper +1. Why is this a big deal? Because it's used in several different tests. But basically, on a molecular level, the reason these guys are considered reducing is because, remember that carbon that I said could become an aldehyde or a ketone? Remember that one? Well, that one is available to open and become open chain in these. It's not available in sucrose or in any of the polysaccharides because the polysaccharides are very, very long and they're all hooked up in alpha-1,4s or alpha-1,6s. Sucrose, it's an alpha-1,2, so anything that could have opened up is locked up. Again, details of this, you don't need to worry about it. But what I want you guys to know is if I ask you what's an example of a reducing sugar, it would be one of these guys. And what does that mean? It means that it can get oxidized and it can reduce Benedict's reagent. It can reduce copper and turn it into a different color. So instead of copper +2 that is blue, it becomes copper +1 that is red. What is an example of a non-reducing sugar? Sucrose is non-reducing, and all the polysaccharides are non-reducing also. Okay, we are done with carbohydrate chemistry, and the next set of videos for week 4 will be all about lipids. Lipids, just a fancy word for fats. Okay, see you then.